Hello friends and welcome to a brand new channel T7T, that is the 7 Thinkers. This channel is all about educational videos, and the first video which is coming up is for the 11th standard students, and that is their most difficult chapter, which is Conic Sections. So without any further ado, let's get started. Conic Sections is one of the most important chapter in terms of clearing JEE examination or your school examinations. In JEE, conic sections hold around 5 to 8 questions, that is 1/6 of the maths paper consisting of just a single chapter. As the name suggests, conic sections. Conic over here means part of a cone, the ice cream cone or the birthday cap, and sections mean that we're gonna divide this cone into different sections. And the figures we obtain by dividing the cone into different sections consist the theory of this chapter. As we know, the father of geometry is Euclid, so this was also the concept formalized by Euclid. So let's begin. So there are 4 conic sections which we're gonna discuss in this chapter, and that is circle, ellipse, parabola, and hyperbola. But before that, we must know the parts of cone. That is, this part is known as the base, the center line known as axis, and the slant height is also known as generator. So as we know that these figures are actually conic sections. So how do we cut a conic to obtain such figures? Let's find out. Circle. When we cut the cone parallel to its base, we obtain the figure circle. Likewise, when we cut the cone in any direction which is not parallel to axis, not parallel to base, or not parallel to generator, we obtain a figure which is ellipse. Parabola is obtained when we cut a cone parallel to its generator, and hyperbola is obtained when we cut the cone parallel to its axis. So this is how conic sections are formed. What we are taking over here is a right circular cone which has 3 parts: base, axis, and generator, and cutting that in different sections give us different conic sections. So now let us discuss what is the definition and equation of conic. The definition of conic is the locus of a point which moves in a plane. But what is this locus? Locus is actually a path which is followed. It is like a trace of a point. So the locus of a point which moves in a plane. So let that point be P of x comma y, as we are taking over here rectangular coordinate system, such that the ratio of its distance from a fixed point. Let the fixed point be S, and let us join that fixed point and the point P with a line, such that the ratio of its distance from a fixed point to its perpendicular distance from a fixed straight line is always constant. So let this fixed straight line be the yellow line, and so PM is the perpendicular distance from a fixed straight line. So actually, what is the definition of conic in general is the ratio of its distance from a fixed point, that is SP, to its perpendicular distance from a fixed straight line, that is PM, is always constant. And this constant is represented by letter E, which is known as eccentricity. But we have something more over here, that is, this point S or the fixed point is known as focus, and this fixed straight line is known as directrix. So SP by PM is equal to E, and this is the definition of conic. So what is the equation of conic? Just using the distance formula, we can find out the equation of conic. Let S has the coordinate as alpha comma beta, and the equation of the directrix be ax plus by plus c is equal to 0. So what will be the value of SP? It will be root under x minus alpha whole square plus y minus beta whole square. Just using the distance formula for S and P. Taking PM to the right hand side, which will be multiplied by the E, that is eccentricity. Now what is PM? PM is the perpendicular distance. And in straight lines, we know that the perpendicular distance to any given point from a fixed straight line is given by mod of the equation by substituting the value of the point, that will be ax plus by plus c whole divided by root under the coefficients of x and y, that is a square plus b square. So now since we have under roots, we're gonna square both the sides and we get the general equation of conic as x minus alpha whole square plus y minus beta whole square is equal to e square multiplied by ax plus by plus c whole square divided by, which is not under the bracket, a square plus b square. And this is the generalized equation of conic. So just applying distance formula, we have found out what is the generalized equation of conic. So all conics which we're gonna study in this chapter will have an equation like this. Now further, we are here with the value of eccentricity for which conic is defined. That is, we have seen that there are four types of conic: circle, ellipse, parabola and hyperbola. So according to the value of eccentricity, we get the nature of conic. For the value of E being 1, we get parabola. E less than 1, we get ellipse. E greater than 1, we get hyperbola. And E is equal to 0, we get circle. So accordingly, we're gonna prove different conic sections and we're gonna get different generalized equation of different conics just using the value of eccentricity. So guys, this is it from the first lecture. I hope you enjoyed it. This is Yojit Bhasin signing off from T7T. Meet you in the next video. Thank you.